Hello everybody, welcome to the Productivity and Performance in Concrete Pouring Practice Exam Question Review. Please also ensure that you revisit the tutorial questions for this topic. So this is not an exhaustive exam preparation study video. It's simply going through how to respond to the practice exam question which was uploaded. So let's jump in. So we've got a scenario here, and again, we're going to highlight the key items and key facts. So we have a total area poured and finished. So it's a concrete pour, so we know what we're looking at there. We've got 180 metre cubed of concrete poured and finished that day for the slab. We have 10 workers on the job for a total of 8 hours. Here we have some additional information that's been given to us, but we might not necessarily need that. So take that on notice, but we don't necessarily need to highlight that. The estimated concrete pour was 6 hours and it took them 8 hours. So this is quite easy because we've got the 8 and the 8. So we don't need to get confused with those hours for how long they were on the job versus how long the pour took. We have the concrete slab was 600 by 0.3. And I did have some students asking, so during the tutorial when we did a similar question, I had some students asking about the units because as well a few students did. It's quite easy to go astray in these questions based on units. So we're going to do a quick recap again, just so that everyone's on the same page. So we've got sort of two key lines here I want you to look at. Total area poured, 180 metre cubed, and then the concrete slab size. Now, I always say there's no such thing as a silly question, so I'm just going to answer the question for you so that you don't even have to try and think about it. So we're doing a very basic little concrete house. We'll pretend, this is the front path. La-di-la-di, looks stunning, a bit of grass, right? Lovely. Gorgeous. This is the slab that we are working on. Now, please excuse my shocking writing on this. Again, there's no ability to add text during recording, which is a bit of an oversight. So we know that the concrete slab is 600 metre squared. So the 600 metre squared is the size of this top section here. Metre. Wow, that's a real dodgy M, but metre squared. Now, the 0.3 metre deep is then obviously when you're pouring concrete, it's not just flat with no depth to it. So we are going to add in, and again, please excuse my dodgy sketching here. We are going to add in the, and this is obviously not to scale, add in the depth of that slab. So we know that the distance between the top of the slab and the bottom of the slab is 0.3 meters. And again, apologies for these deplorable sketches. Now, what do we get when we times or when we multiply 600 meters squared by 0.3 meters? So if we have 600 meters squared, which is the size of the top of the slab, meter squared, there we go, times by the depth. So we have the area on top times by the depth of that same area. And for those of you who are familiar with this, please feel free to skip ahead. So we have here, let's do the units first. So we've got a metre squared multiplied by a metre. So we know that that is going to give us metre cubed. So that's the volume. So technically, this question is a bit misleading because this should really say the volume. Ooh, wow. And that should look like a V. I'm going to give up on that. There we go. That should be the volume poured. And we know that 600 times 0.3 is 180. So that's just to explain to you where we get these three values from and what they actually mean in terms of the concrete slab. All right, so we've got those details. We know we've got some equipment, so we're going back to our question and highlighting the key facts. So we've got a concrete boom rented, $300 an hour. Got a concrete vibrator owned, and we are Schmidt Concrete, so we don't have to worry about that. Floats and other handy tools owned again. And then we know that all plants used were running pretty much the whole time while the concrete workers were pouring the concrete. But the concrete pump was running for a total of 5 hours. So the majority of tools were used for the approximate 8 hours, but the concrete pump was running for 5. And we've been asked to calculate labour productivity, equipment productivity, the unit rate on the amount of concrete poured and the actual hours of the workers, and to find the performance factor. So again, before you attempt this question, please have a look at the notes for this week's topic, go through the tutorial question, review your answers, then attempt this and use this video to guide you through your answers, or if you get stuck, please do not use this as your only revision. So pause if you need, and then we'll get into it. So we're going to start off with labour productivity. So there's the equation for those of you who need a little refresher. When responding to this type of question, always put the equation first. So we're going to put the equation, we know what we're working with, and then as well it's a bit easier. So we know here the units that we are looking for. And if we pop it all down first, it's a lot harder to make those mistakes that are sometimes very easily made during an exam when you're stressed or you're not thinking straight or you've got a time limit and you're a bit frazzled. So equation first so that we don't mix it up. Units always start in the equation. And then how do we finish it? So if this was the exam, and obviously currently we're doing online exams, so you can write it out like this. You don't need to use that Microsoft equation or whatever and upload that. I'm quite happy for you to write it out like this. Just make sure you're using the right number of brackets and things like that. So we've got total area poured in meters squared divided by the total worker hours, which is workers times by hours. So we have the total area poured, and we know here that this is in meters squared. So that's why we know we're looking at this unit. If you don't put the units here, a lot of students might put 180 instead of the 600, and that's where you're going to get into a bit of trouble. And then worker hours, so we have how many workers? Well, we know that we have 10 workers, so we're going to pop that in. And how many hours? 8 hours. Done. Now again, if the pour took a different amount to the number of hours on site, that would need to be something that you flag, because obviously we've got 8 hours here as well, so it's quite simple, but you do need to be aware of that. And then we have a total of 7.5 meters squared per hour. So it's not too difficult. The hardest thing is really making sure that you are picking the right equation and making sure that your units are correct. And obviously have a calculator on hand for the exam. All right, then we're going to look at equipment productivity. So again, what's the first thing we're going to do? We're going to that equation. So here we are looking at total volume of concrete, which is that meter cubed. And again, this really should say total volume poured to be accurate. And then we have total equipment hours. So let's just, again, we're going to write it out because we are doing an exam. Total volume of concrete meter cubed divided by total equipment hours. So we have 180 meter cubed divided by 5 hours as the concrete pump ran for 5 hours, which we know from here, which means that for every hour we are doing approximately 36 metre cubed. And again, we're making sure our units are in there the whole way, and we're showing our working, even here, right, why you've picked a certain hour, if there's something up for debate, because you will get marks for working, even if your end result isn't exactly the right number. Obviously, you won't get full marks if your answer is not correct, but you do get marks for working. So show me your working, show me how you got there. Do not just write 36 metre cubed per hour, because you don't get full marks for just putting that. You need to show me your working. Next, we're going to look at the unit rate on the amount of concrete poured and the actual hours of the workers. And I guess on this topic, this particular type of question is something that you can actually work through fairly quickly if you've got your notes in order. So if you know what information you're looking for and you know what equations that you are using or going to be using, you can actually really save some time during the exam. Say you've allocated, if this question is worth a certain percentage and you've allocated that it should take you 24 minutes to do, say, you might be able to get it done in, say, 10. Then you've got an extra 14 that you can use on a trickier question that maybe you didn't do so much prep for or you're not as confident in. So this type of question is definitely worth practicing, because if you can get to the point where you know exactly what units, exactly what pieces of information you're looking for, you can really save some time in the exam that you can use to make. So to calculate unit rate, we are taking the total work hours and dividing that by the total area poured in metre squared. So we have 10 workers working for 8 hours and 600 metres squared of concrete being poured in that time, which ends up with 0.133 man hours per metre squared, or man hour per metre squared, or hours per metre squared. All of those unit rates will be accepted as correct in your exam. Then finally, we're looking at the performance factor for this particular concrete pour. Again, what are we going to do? We're going to start off with our equation. So to find the performance factor, what we need to do is take our estimated unit rate and divide it by the unit rate of the actual pour, so what actually happened on site. And if you've worked through from questions 1 through to 4, the unit rate is taken from question 3. So you've already calculated that bit. So now we're just going to calculate the estimated unit rate. So we have it that it was going to be an estimated 6 hours to complete the pour with 10 workers on site. And how big is the pour? The pour is 600 square meters. We are then going to divide that by the unit rate. So we end up with 0.1 man hour per meter squared divided by 0.133 man hour per meter squared. Now that 0.133 has obviously just been capped because our result from question 3 was very long, but that's okay. 3 decimal points is plenty. It won't affect your end result there. So we have 0.1 divided by 0.133. Why? Because the man hour per meter squared cancels each other out in this particular equation, and we end up with 0.5. Now this step here is optional. I do like to include it though, as some students in an exam would like to do a little check, make sure that they're on the right track. So we can run a check now for the performance factor. So we know that it's 0.75. However, if we're going, oh, I'm not sure, did I get it right in question 3? What is my unit rate correct? Am I using the right values? A great way to do a check, and I reiterate, this is only a check. This is not the answer. So technically this equation is not the equation, but it's a very handy little check and it takes 2 seconds. So I'm showing you so that you can check your responses, and it helps sort of know if you've answered question 3 and question 4 correctly. You can kind of mark yourself as you go. However, if you just include this equation without the unit rate information that we did on the previous slide, you will not receive full marks. So this is to check, we do estimated duration over actual duration of the pour. So we know that the performance factor is the estimated duration over the actual duration. which is 6 hours over the 8 hours. How do we know this? This line here. And again, if the 8 and the 8 were different, I've made it easy for you because they're both 8, but if those two were different values, you would need to make sure you're using the right one, which is the actual duration of the pour, not how long the workers were on the site for. And we have our performance factor of 0.75. Similarly to the other questions, when we look at, say, for example, CPI and SPI, is a high distinction answer going to leave it here? Absolutely not. We're going to say something about what that value means for the project. So we've got performance is lower than expected, and a high distinction response would actually write that in a full sentence about what that means for the project. I hope you found that helpful. Please make sure you review your tutorial questions, this one and any other practice questions that you've been given throughout the study period, and good luck with your exam preparation.